the equation of the three asymptotes to the curve y equals to x minus 2 squared all over x plus 3 into x minus 4 are a, b, c, or d. A curve of a function can have vertical asymptote, horizontal asymptote, or oblique asymptote. Let's say y is equals to a rational function f of x all over g of x. To get the vertical asymptote, you just set the denominator g of x to be equals to 0. And then look for the values of x or the value of x. The value of x that we will obtain will be the vertical asymptote of the curve. Let y equals to x to the m plus all over bx to the n plus where x to the m plus others is a polynomial and bx to the n plus others is another polynomial, where the degree of the polynomial at the numerator is m and the degree of the polynomial at the denominator is n. If m equals to n, y equals to a over b is a horizontal asymptote. If m is less than n, y equals to 0 is still a horizontal asymptote. But if m is greater than n, there is no horizontal asymptote. That means the curve have an oblique asymptote or a slant asymptote. Let's say y is equals to f of x over g of x. Given that the degree of f of x is greater than the degree of g of x, then we can get the oblique asymptote of the curve by carrying out a long division of f of x by g of x. Let's say we carry the long division and have y equals to q of x plus r of x all over g of x. Then the oblique asymptote is y equals to q of x. That is the quotient of the long division. Now to get the vertical asymptote of this curve, we need to set the denominator to be equals to 0. That is x plus 3 into x minus 4 equals to 0. This means x plus 3 is equals to 0 or x minus 4 is equals to 0. That is x is equals to minus 3 or x is equals to 4. That means the vertical asymptotes are x is equals to minus 3, x is equals to 4. So now we need to find out whether this curve have an oblique or a horizontal asymptote. You know, when a curve has an oblique asymptote, then it will not have a horizontal asymptote again. And if a curve has a horizontal asymptote, it will not have an oblique asymptote again. To find out, we need to expand the numerator and the denominator to compare the degrees of the polynomials. That is y is equals to x squared plus 2 squared minus 2x all over x times x minus 4 plus 3 times x minus 4. To expand this numerator like this, I've used the algebraic formula a minus b all squared is equals to a squared plus b squared minus 2ab. That's how I got this. You know, y is equals to x squared minus 2x plus 4. Since 2 squared is equals to 2 times 2, which is equals to 4, all over x squared minus 4x. Since x into x minus 4 is the same like x times x, which is x squared, minus x times 4, which is 4x. You also know 3 into x minus 4 is the same like 3 times x, which is 3x, minus 3 times 4, which is negative 12. So here will be plus 3x minus 12, which is equals to x squared minus 2x plus 4 all over x squared minus 4x plus 3x is minus x minus 12. You see the degree of the polynomial at the numerator is 2 and the degree of the polynomial at the denominator is also 2, and the coefficient of the x here with the highest power is 1 and the coefficient of x here with the highest power is also 1. It means the horizontal asymptote is y equals to 1 on 1, which is the same like 1. Know the degree of the polynomial, we always take the highest power of the variable in the polynomial. For this case, we have the variable x. You see the highest power of x here is 2 and the highest power of x in the denominator is 2. So you see this polynomial has one horizontal asymptote which is 1 and then 2 vertical asymptote which are minus 3 and 4. So the right answer here is this one, which is B.